Today, we're going to be working on simplifying and dividing rational expressions for our quiz tomorrow. The first part of our quiz review is all about factoring out the greatest common factor of our rational expressions and seeing what we can cross out and cancel and then reduce. So what we need to do is we need to look at the numerator and the denominator separately. We first want to factor the numerator, meaning we want to ask ourselves, what multiplies to 3, or rather what divides both 3 and 18? You said 3, you're correct. So we write 3 because 3 divides both 3 and 18. And then we divide. 3x divided by 3 is x, and 18 divided by 3 is 6. Now let's do the denominator. 9x and 54. What divides both 9 and 54? 9 divides both 9 and 54. So we're going to put that in the front. 9x divided by x, or sorry, 9x divided by 9 is x, and 54 divided by 9 is 6. So now what do they have in common? What can we cross out here? They both have an x plus 6. So that leaves us with 3 over 9. We are not done yet because both 3 and 9 are divisible by 3. So if I take 3 and divide that by 3, I'm left with 1. If I take 9 and divide that by 3, I'm left with 3. So that leaves your final answer as 1/3. Let's do problem number 2. Problem number 2, we have 4x plus 12. So we want to factor out, what do they have in common here? 4 and 12 are both divisible by 4. So we're going to write 4. 4x divided by 4 is x. 12 divided by 4 is 3. Now let's do the denominator. We have 5x and 15. 5x and 15 are both divisible by 5. So we can say 5x divided by 5 is x, and 15 divided by 5 is 3. What do they have in common? They both have an x plus 3, so we can cross that out. What's left on top is 4. What's left on bottom is 5. And that's how we simplify our rational expressions, by factoring out a greatest common factor. I'm going to go ahead and clear that out. So if you need to pause the video, go ahead and pause it. All right, scrolling down. Now we're going to look at how we can simplify the already factored rational expressions. So for this first one, they're already factored. So we're just going to cross out what's the same in the top and the bottom and write what remains. So we have an x plus 8 on top and an x plus 8 on bottom. That leaves us with an x minus 1 on top and nothing left on bottom. So you can do 1, or you can, because it's just the top, you can write x minus 1 as your final answer. Either one would be fine. I have, for number 4, I have an x minus 6 on both the top and bottom. So I cross those out. What's left on top is x. What's left on bottom is x plus 7. And that's your final answer. Finally, for number 5, we see we have an x plus 4 on the top and the bottom. So we're going to cross those out. We see that we have an x minus 7 left on the bottom. So I put it on the bottom of the division sign. But since there's nothing left on top and you can't just leave it blank, you use a 1 as a placeholder there. All right, let's look at problem number 6, 7, and 8. They want us to simplify each rational expression by factoring the quadratics, either through the, doing the x squared, what multiplies to or adds to. And then if you look at number 7, we have a little greatest common factor factoring that we need to do here. So for when we factor our quadratics, we say what multiplies to 14 and what adds to 9. So what multiplies to the last number and what adds to the middle number. So thinking of the numbers that multiply to 14, we would say 1 times 14, 2 times 7, and that's about it. So which pair adds to 9? 2 and 7 does, right? So we can change that to be x plus 2 times x plus 7. On the bottom, we have x plus 2. That's already in simplified form. So we just rewrite that. I notice I have an x plus 2 on top and bottom. So we cross those out and we're left with x plus 7 as our final answer. Looking at problem 7, we said there was this greatest common factor factoring that we needed to occur here. So we have 4x minus 12. So we have what divides both 4 and 12. We know that that's 4. And we're left with x minus 3 because we could say 4x divided by 4 is x. 12 divided by 4 is 3. And now we go ahead and factor the denominator. What multiplies to 24 and adds to negative 11? That's going to be negative 8 and negative 3. We cross out what we have in common, which is these x minus 3's, and we're left with 4 over x minus 8. And that's our final answer there. And then for problem number 8, we see that we have a quadratic both in the numerator and in the denominator. So we say what multiplies to 45 and adds to 14. So you got to think of all the numbers that multiply to 45. If you got 9 and 5, you are correct. And now we have to do the same thing for the bottom. What multiplies to 27 and adds to 12? We have x plus 9 and x plus 3. The x plus 9's cancel because we have one on top and one on bottom. That leaves us with x plus 5 over x plus 3. And that's your final answer for problem number 8. I'm going to go ahead and clear this out. So if you want to take a minute and pause the video if you need to, go ahead and do that now. And clearing it out. There we go. We're going to scroll down. We have 2 more concepts we're going to cover. The first is multiplying rational expressions, and we want to make sure that they're in their simplest form, as well as dividing rational expressions and putting them in their simplest form. So when we multiply rational expressions, very, very, very similar to when we are just simplifying them. We just have 2 fractions now. So we just have to factor each of the numerators and denominators and cross out any common factors that we have. So for the first one, we have 6x plus 12. I notice there's no x squared here, so I can't put my 2 parentheses, but I recognize that there's a number in front of x. So I ask myself, can I simplify out a greatest common factor? And the answer is yes. What number divides both 6 and 12? And that number is 6. So I have x plus 2 left after I take out a 6, because 6x divided by 6 is x, and 12 divided by 6 is 2. Now draw a line. What multiplies to 21 and adds to 10? That's going to be x plus 7 and x plus 3. We're not done yet. We have to do the other side of our multiplication here. We still have to factor these. So we have what multiplies to 28 and adds to 11. So we say that's x plus 4, x plus 7. And then again, we're going to pull out a greatest common factor here. I know it's a greatest common factor because there's no x squared and there is a number in front of x here. So we say we're going to factor out a 2 because 2 divides both 2 and 12. So 2x divided by 2 is x. 12 divided by 2 is 6. Now let's cross out what we have in common. I see I have an x plus 7 on top and on bottom. Those can cancel. And maybe a little less common than we're used to dealing with is a 6 and a 2 on top and bottom. So I have a 6 on top and a 2 on bottom. That can reduce because they're both divisible by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So you get 3 over 1 or just 3 on top. So we have 3 times, what else is left on top? X plus 2 and x plus 4. On bottom, we have the 1, or you don't have to write anything at all, and then x plus 3 and x plus 6. And that's your final answer for this problem. For 10, we have 4 quadratics we need to factor. So just a lot of asking, okay, what multiplies to the last number and adds to the middle number? So what multiplies to 24 and adds to 10? So that's x plus 6 times x plus 4. On the bottom, we say what multiplies to 12 and adds to 7. That's x plus 3 times x plus 4. Oh, that's a 4. We do our multiplication symbol and we do the second equation. What multiplies to 28 and adds, oh, I forgot to mention this was a typo. This should have been 11. And what adds to 11? So what multiplies to 28 and adds to 11, that's x plus 4 and x plus 7. And we're going to now do the bottom equation here. What multiplies to 42 and adds to 13, that's x plus 6 and x plus 7. So now we're just going to cross out what we have in common. We have an x plus 6 and an x plus 6. We have an x plus 4 and an x plus 4. And we have an x plus 7 and an x plus 7. That leaves us with an x plus 4 on top and an x plus 3 on bottom. All right, I need to go ahead and clear that out. So pause this video now if you need to get this information, if I went a little quick for you. And clear it out. Let's go ahead and scroll down to the last two questions on our review, which is dividing our rational expressions. Now remember, there's one major rule we have to remember when we're dividing our rational expressions. And that rule is that if we have the division symbol, that means we're going to flip the second fraction. Okay, so I'm going to rewrite the first one, x plus 4 over x squared plus 9x plus 20. I'm going to change to multiplication and I'm going to flip this. So it becomes x squared plus 14x plus 48 over 2x plus 12. And now we factor it. So x plus 4, that's in its most simplified form. So I'm going to leave that alone. But what multiplies to 20 and adds to 9? That's x plus 4 and x plus 5. So those 4s are going to cancel. Just jumped on that right away. Next, we say what multiplies to 48 and adds to 14? That's x plus 6 and x plus 8. And lastly, this is the greatest common factor problem here. How do I know that? Because we have no x squareds here, and there's a number in front of x. So you ask yourself, what divides both 2 and 12? And I know 2 divides both of those. So I'm going to draw 2 here. 2x divided by 2 is x. 12 divided by 2 is 6. Now I can finish crossing out what they have in common. That leaves me with an x plus 8 on top and a 2 times x plus 5 on bottom. All right. Very last question here. It's division. So we're going to rewrite the first fraction here. So I have x squared plus 12x plus 32. And that's being divided by x squared plus 5x plus 4. I'm going to change that division to multiplication and flip the second fraction upside down. So x squared plus 7x plus 12 is now on top. And x squared plus 11x plus 24 is now on bottom. So now we're going to go ahead and factor these. So what multiplies to 32 and adds to 12? This one was kind of a tricky one, but if you know your multiplication tables, you figure out that it's 8 and 4. 8 times 4 is 32, and 8 plus 4 is 12. For the bottom, what multiplies to 4 and adds to 5? So we say x plus 4 times x plus 1, because 4 times 1 is 4, and 4 plus 1 is 5. We have 2 more to factor here. What multiplies to 12 and adds to 7? We did this one earlier. We know that it's x plus 3 and x plus 4. And lastly, what multiplies to 24 and adds to 11? That's x plus 8 and x plus 3. So now we go ahead and cross out what we have in common. I have an x plus 8 on top, x plus 8 on bottom. I have an x plus 4 on top and an x plus 4 on bottom. I have an x plus 3 on top and an x plus 3 on bottom. That leaves me with x plus 4 on the top and x plus 1 on the bottom. So that's it. That's everything you need to know for our upcoming quiz on simplifying, multiplying, and dividing rational expressions. Please take the time to study, and good luck.